Hey guys, welcome back. Before I get into the video proper, I do want to point out up front that this video didn't go the way that I hoped it would, in that it didn't work. Call it a poorly thought out design that I committed to when I really shouldn't have, and when I eventually did get it to work, a loose screw coupled with the bad design meant that it didn't work. Now normally I just scrap the project and start from the beginning again, which is something that I've done before when things just don't pan out the way that I hoped it would. But this time around, I think it's worth looking at as a bit of a case study in sort of what I shouldn't have done, where it went wrong, and when I eventually redo it in the future, it'll be interesting to see what I do differently. With all that said and out of the way, let's start from the beginning. I'm sure most of my long-time viewers will recognise this tool. It's my homemade hand scraper, which is used for surface scraping machine tools. If you're not too familiar with it, it's essentially a process by which you scrape away material from the face of a workpiece in an attempt to match or recreate a flat surface. As an example, I had to scrape the vise which I use for the mill. I didn't pay a whole lot for the vise, so it wasn't a huge surprise when it turned out that the vise wasn't very flat. I don't have a surface grinder, so I had to scrape it using my granite surface plate as a reference. The surface plate is good to within about 5 microns across its total area, so that's probably as good as I was able to get the vise. So what you do is you cover the surface plate in an oil-based dye, and then when you put the two in contact, the high spots on the vise will get a blue coating. This shows up as the high spots, and anything that doesn't get coated is a low spot. You then take the scraper and then you physically scrape away the material to remove the high spots. You then go back, check it again, scrape the new high spots, take it back, check it again, scrape the new high spots, and do it again and again and again until you have an even distribution of blue spots. When it looks like this, the vise is now flat across all those blue spots. And that's what we're aiming for with scraping. Yes, there are low spots, but the main goal here is to get a good spread of contact points that are the same height. The low spots though do have a purpose because we use them to trap oil and it helps keep the surfaces oiled, which is something that you wouldn't get with a perfectly smooth surface on something like a surface ground part. Now apart from the vise, I've also scraped in the mill saddle and its gibs. Which brings me to now. The lathe will soon get a new cross slide and a new set of gib strips, and I'm going to have to scrape those in to help them retain oil. I'm also 50-50 on getting a new CNC mill or lathe, and they'll probably need scraping too at some point. Which is fine and all, except scraping, it takes quite a long time to do. Obviously it will be dependent on how far out of flatness the part is and how big it is, but I remember it taking at least 3 or 4 days to get the vise parallel and flat on each side, and the vise, it was not a big project. Thankfully though, electric power scrapers are a thing. They cut down on both the effort and the time that it takes to scrape a machine tool. And I would love one, except for the fact that they're not exactly a common item. And when you go to the manufacturer's website, it says to contact them about pricing, which is a subtle way of saying that this tool is going to be crazy expensive. And from what I can tell, even a used one is going to run you at least $1,000, which is a lot for a tool which I'll probably use maybe once a year. And that's where this project starts, with a reciprocating saw. This one here was the cheapest one that I could find, it was open box and I got it for like $30. This really isn't a project to sacrifice a good one over, so just get the cheapest one that you can get. The plan here is simply to convert the reciprocating saw into a basic power scraper. The motion of it is almost identical to what you'd find on a power scraper, so it's really a no-brainer. And obviously I'm not the first person to think about doing this, although I have seen a few different methods on how to approach this. Now my first thought was to see if I could simply just bypass all of this and make a scraper blade that would directly connect to the saw in the same way that any other saw would. So with a simple sketch later, and I had a basic running plan. The only real thing that I need here is that the blade needs to drop down so I can scrape it at the correct height and angle. The piston here is just a little bit high compared to what you'd find on a normal scraper. So I'll sacrifice the blade that came with it, and then I can weld on a piece of bent steel, and then I can attach the carbide scraper blade to it. And that is the basic scraper now done. It's a bit uglier than what it was in the sketch, but you do get what you pay for. And in my case, I didn't pay myself anything. Okay, so probably to no one's surprise, that didn't work. But it did show why the modifications are needed and what modifications will be needed. The big one is going to be the stroke length. That's going to be the amount of travel on the piston. I measured it earlier and it came out to being about 18 millimeters, which is really far too long for this type of small scraping work. I'll have to do a bit of testing later on to see how long the stroke really needs to be, but I'm sure it's going to be closer to about 3 or 4 millimeters than 18. And that also means that the stroke length needs to be adjustable, which it currently isn't. Secondly, the scraper blade needs to be more rigidly attached. This arrangement, whilst it was easy to make, just wasn't up to the task. It isn't as rigid as I'd like, and once it started to hit the cast iron, it started to move all over the place. And I can't have that when I'm trying to do precision scraping. So with all that in mind, let's get this thing apart. Alright, and that's the internals of a reciprocating saw. From what I understand, this arrangement is called a Scotch yoke. And all it basically does is it converts rotational motion from the motor and the gearbox to a linear backwards and forwards motion. Thankfully though, all of this means that the design itself should be pretty simple. Now the first thing that I noticed once I got it apart is that there's currently no way to change the stroke, and unfortunately there's a stud in the center that the gear mounts onto, and that's going to make moving the pin inwards a little bit difficult. What I need to do first though is get the gear pulled off. Thankfully it's made of steel, so I can fashion up a gear puller of sorts and get this thing pulled off. So I'll weld in a piece of steel and then I'll drive a screw or a bolt, and that should push against the center pin and push the gear off. With the gear now off, we can now see that it's using a helical tooth pattern to mesh with the motor. Now that's probably not a huge surprise, but that's not a good thing for me because I don't currently have any equipment which can be used to recreate this gear tooth. I am able to cut straight tooth gears, but not true helical ones. And that leaves me at a bit of a hard decision because what exactly do I do here? Do I redesign the gearbox, change out the input and the output gears to a gear type that I can make? That would probably require significant modifications to the housing, but if I do that, I can simply remake the face gear with all the adjustment features that have been built in, sort of with it in mind. Or do I simply try to work within the existing constraints of the existing gearbox and try and find a way to move the pin in and out without having to completely redesign everything? Now the smart move probably would have been option 1, but I chose option 2 and unfortunately I made a real hash out of it. Now the first thing I did was remake the piston. I'll be attaching the scraper to it, but more importantly, the part that the bearing fits into needed to be raised by about 10 millimeters. This would be to accommodate the adjustment mechanism. With the piston now made, I now need to modify the gear. Now there's material that's been removed on one side, and my best guess is that it's been done to help balance the mass of the gear. But unfortunately, it meant that there wasn't a whole lot of material to work with. Now the smart design here would have been to face off the top 5mm or so, and then weld on a new plate on top of it to work on. But I didn't. I simply decided to work around it, and that was probably the biggest mistake here, because it started to box me into a corner. So what I'm doing here is I'm adding a track for the adjuster to sit in and slide in. This should have been fine and all, except I only added one screw, which will probably come back to haunt me in a little bit. The track also needed to be as shallow as possible, since I still needed to mount the gear back onto the shaft. This meant that when it came time to designing the adjuster, I'd also run into another issue. Speaking of which, I'll be using a shank from an old tool holder to make it from. I'll get it in the milling machine and then take a chunk off the top before machining a step down at the back. Now I'll admit here that this probably wasn't my smartest hour, but I needed to take a millimeter off the top of the pin, and instead of removing it, I simply went to town on it with a Dremel. You can now see pretty clearly how I can move the pin in and out and then hold it in place. All in all, it looks okay at the moment, but in a minute you will see exactly what the issue is. First things first though, I do need to weld on the scraper blade. Now in this first test, I mean it wasn't perfect, but in spite of everything, it was removing a ton of cast iron and it was doing it really quickly. You know, way more than I could do in 20 seconds. So at least on one hand, I had a proof of concept and it was working. The problem here though was the wobble. I mean, I could see it pretty easily and I'm sure it's pretty evident on the film. Pretty obvious that I only want it moving backwards and forwards. So, well, what's going on? On the original design, you can see these two metal rods that pressed up against the part that housed the bearing. This was simply there to prevent the piston from tipping side to side. And I didn't have that on my design. I used the bearing itself, making sure that it stayed in perfect contact with the piston to keep it level. Because there always needed to be some amount on the other side to prevent the other side from tipping up. Which is fine in theory and on a sketch, but here there was evidently a gap of some sort, and that caused the rocking that you can see here. Now I simply tried replacing the bearing with a bushing that was a little bit taller, and that seemed to fix most of the issues. Although I only got that working for a minute because, unfortunately, the screw for the adjuster came loose, it jammed up against the piston, and that cracked the bushing block screw. All around, not good. The other crack though was my fault. That was just me tightening up the vise, and that wasn't related to this. Now my best guess here is that the stud wasn't the right height. It caused a bit of vibration, that caused the screw to loosen, and then the adjuster jammed, and here we are here. So that's pretty much $30 and 2 afternoons worth of work down the drain. Not the biggest loss, but it's still pretty frustrating. Definitely a good lesson to learn here. You know, try to keep it simple doesn't always work out the best. There's definitely several points here that I should have realized that I should just abandon it all and start from the beginning. But that's the whole sunken cost thing. You know, I've already spent too much time working on it, so I kept on working on it. And as a result, I lost pretty much everything. With all that said though, there is certainly a design here that's worth pursuing, and I'm currently in the middle of redesigning it, so sometime in the future I'll come back, obviously with a new one that's not cracked, and I'll hopefully give it another go, and fingers crossed it'll work out a lot better next time. And with that, thank you very much for watching, hope you found this video valuable and interesting, and I guess I'll see you next week.